Hi, today we are learning about block design in experiments. This is a pretty big idea. Um, Comes up often on the AP exam. Block design is a group of experimental units or subjects that are known before the experiment to be similar in some way that is expected to systematically affect the response to the treatments. In a block design, the random assignments of units to treatments is carried out within each block. This shows the process of cancer treatments. They know that the men and women respond differently to cancer treatments, so blocking by gender will give the desired response. So you take the subjects and divide them into men and women, and then we do a random assignment into their groups. Group 1 takes therapy 1, group 2 with therapy 2, and group 3 with therapy 3, and then we compare their survival rates. Now the blocking in this takes place right here. This is the blocking. We divide them into groups before we do the random assignment. Now some blocks, after they're done, will want to compare at the end to see what worked and what worked for men and what didn't work for women. Now, a fitness instructor wants to see the effectiveness of an upper body workout. He initially tests people on the amount of push-ups that they can do in a minute. He wants to compare people with similar abilities. So what he can do is take the subjects, and upper body strength might be different for men and women. So we have men here, women down here, and then the next step is to randomly allocate. Now, we're going to have two different groups. One group does the workout. So, well, first we want to put them in groups. So here's group 1, if I can spell group. And here's group 2. Group 1, group 2. And group 1 might do the workout, or group 2 doesn't do the workout. So at the end, we'll want to compare. So you can see how the women do, and then he'll want to compare to see how the men do. And he might actually want to compare both of these and see how the men do versus the women. There is a type of blocking where we have paired samples, where each data point in one sample is matched to a unique data point in the second sample. Uh, Matched pairs is a common form of blocking that compares just two treatments. So two types of match pairs are match pairs of a subject into groups that are very similar. One subject gets one treatment and then the other one doesn't, and then they compare the results. There's another type of match pairs where each subject will receive both treatments in a random order. So first one person will get it and the other person doesn't, and then they switch the order, and then they can compare how things worked out. There's an AP test question about waterproofing boots, where a manufacturer wants to test how well their waterproofing boot their boot waterproofer, I don't know how to say that, how good it works. So they asked what method can they use to see how well the new waterproofing works. So what the AP was looking for was they wanted people to block by each person. They want to take both of the boots, and so there's however many different people. Say say you take 5 different groups and divide them up. So boot 1, boot 2, boots 3, boots 4, and boots 5. And then in each of these, we're going to randomly allocate. So randomly, we're going to choose which boot um, gets the treatment. So so sometimes we're going to, maybe group 1 will get the treatment, meaning the new waterproofing, and the other boot will have the control, which will be the old method of waterproofing. So in each of these groups, one of them gets the treatment and the other one gets the control. And we do this with um, each person that we use in the experiment. All right, that was a lot of writing. And now at the end, we want to compare. Compare these, compare these, compare these, compare these, and see how the new waterproofing method does. Notice how we used random allocation to put the waterproofing on the left or the right boot. And we could have said 10 people, 20 people, but that would have been a lot of writing. But hopefully you get the idea on how you can set up an experiment um, using blocking. Double-blind experiments. In a double-blind experiment, neither the subject nor those who measure the response variable know which treatment a subject received. So this is really common in medical studies, where the nurse that walks into the room to give the patient the pills doesn't actually know which pill is a placebo and which pill is the actual drug. And and there's always somebody that keeps track and gives them which pill to give. Um, but neither the patient nor the person administering the drugs knows knows what's happening. Now, when is it a good idea to use a double-blind experiment? Uh, Mostly when the the attitude of the person giving the treatment can give away what's happening. So if a nurse knew that she was just going to give somebody sugar pills, maybe after a while she would get a bad attitude about it, or somehow give it away that what she's giving them isn't actually going to work. Now this isn't on your sheet, but all experiments need to have some sort of realism. That means that this is when an experiment cannot realistically be replicated, producing the same or desired result. One example the book gave was placebo cigarettes. Um, what they did is they took some marijuana cigarettes and then gave some fake marijuana cigarettes, and they split them up into different groups. And when people smoked the marijuana, they got angry when it didn't work. So, it worked on some people and not worked on, and it didn't work on other people, and people knew right away what was going on, and so the people complained. They could tell that what they were using wasn't the real thing. So they have to the patient has to not know that they're getting the placebo. Like if the even in a if they're taking a pill, if the pill looks different or the pill looks like a sugar pill in some way, uh, it, if it doesn't look like the drug that actually works, it could throw off the study. All right, here's your homework for tonight, number 45 through 50.